Let's take a look at multiplying fractions. It says here to multiply fractions, multiply the numerators and multiply the denominators. So that if you look at it algebraically, you would multiply A times C and B times D to get your answer. As long as these two numbers down here, B and D, neither one are a 0. So looking at the example, you would multiply 3 times 1, which gives you 3, and you'd multiply 4 times 2, which gives you 8. So you would end up with the fraction 3/8 when multiplying 3/4 times 1/2. It says here the green area in the area model below shows the product of 1/3 and 1/2. 1/6 of the second circle is shaded green. So 1/3 times 1/2 equals 1/6. Let me show you what they mean. We sometimes can say take 1/3 of 1/2. And that literally means to take 1/3 times 1/2. What is 1/3 of half the circle? Well, I would have to divide half of that circle into thirds. And the easiest way to do that is to just divide the whole circle into 6. By doing that, I've now got 3 pieces of that half. 1, 2, 3. And taking one of those 3 pieces would be taking 1/3 of that half. And so what I end up with is 1/6 of the entire circle. So 1 out of 6 pieces. And so that's what they're showing you here. Take a look at example number 1. It says find 1/6 times 2/3. Write the product in simplest form. So to find 1/6 times 2/3, I just need to multiply straight across the top and straight across the bottom. So 1 times 2 equals 2, and 6 times 3 equals 18. Because 2 over 18 is not in its simplest form, I'm going to divide both the 2 and the 18 by 2. And that's going to simplify that fraction down to 1/9. You need to simplify your fractions at the end of each problem. See if you can do problems 1A, 1B, and 1C on your own. It says here, if the fractions have common factors in the numerators and the denominators, you can simplify before you multiply. So for example, in example 2, it says find each product, write it in simplest form. It says 3/4 times -7/9. So the first thing I would look at here is the fact that we have a negative fraction. So I need to think back to my integer rules and go, what do I get when I multiply a positive times a negative? Well, we know that if you multiply a positive times a negative, the answer will be negative. Please take care of that first. So now that we are doing the calculations, we don't have to concern ourselves with whether or not the answer is positive or negative. We can simply focus on the math. You can see that 3/4 and 7/9, if we multiply straight across the top and straight across the bottom, we're going to get 21 over 36. But I would like for you to try and keep all of your numbers small. So what we're going to do is we're going to try to reduce anything we can before we multiply. So for example, take a look at the numbers 3 and the number 9. One of them is on top, one of them is on the bottom. I can take any numerator and any denominator, and I can reduce them as if they were a single fraction. What would the fraction 3/9 reduce to? Well, they're both divisible by 3, so I can mark this 3 off, divide it by 3, and make it a 1. I can take the 9 divided by 3, so mark it off, and turn it into a 3. So now I've simplified 3/9 down to 1/3. I can multiply straight across the top again, and I get 1 times 7, which is 7, and I can multiply straight across the bottom, 4 times 3, and I get 12. Notice by doing that, 7/12 cannot be reduced. If I simplify before I multiply, I should not have to simplify at the end of the problem, which is also a benefit. Let's look at another one. Take a look at example B. 2 1/3 times 2 5/7. First, notice that these are mixed numbers. Before I can do the multiplication, I need to change these into improper fractions. So what I'm going to do is I'm going to change 2 1/3 into its improper fraction by multiplying the denominator times the whole number, 2 times 3 equals 6, and adding the numerator, 1, to make it 7. I keep the denominator, 3, the same. And then I'm going to do the same thing with 2 5/7. I'm going to multiply the 7 times 2. I'm going to get 14. And then I'm going to add the 5 in. That gives me 19. And I write that back over the 7. Now, when I look at these two fractions, hopefully you will notice that there is a numerator of 7 on the fraction on the left, and there is a denominator of 7 on the fraction on the right. When you have the same numbers on top and bottom, those numbers actually cancel each other out. Because 7 divided by 7 equals 1, it's like they're not even there. And so what I end up with when I multiply straight across the top and straight across the bottom is a 19 on top and a 3 on the bottom. That is an improper fraction, so I will need to change it back into a mixed number before I am done. How many times does 3 divide into 19? It goes in 6 times. 6 times 3 is 18. So when I subtract that from 19, I will get 1 left over, which I will put back over 3. So 2 1/3 times 2 5/7 equals 6 1/3. That should allow you to do problems 2A, 2B, and 2C. That brings us to evaluating expressions with fractions. It says variables can represent fractions in algebraic expressions. It says evaluate 1/2 times A times B, where A is equal to 6/7 and B is equal to -4/9. So I would rewrite this expression as 1/2 times 6/7 times -4/9. Like we established in the previous examples, you can simplify fractions any numerator with any denominator. So when I look at this, there are multiple things I can reduce. For example, I can reduce the 2 with the -4 by making the 2 into a 1 and the 4 into a -2. Also, I can see that there is a 6 and a 9, which are both divisible by 3. 6 divided by 3 is 2, and 9 divided by 3 is 3. By simplifying those numbers down, I've now created a much easier multiplication problem. Now, I have 3 things that I'm multiplying here, and one of them is negative. We know from our integer rules that if I have one negative number in a multiplication problem, I will have a negative answer, and I need to take care of that right away. I could have actually taken care of it before I simplified, so that I make sure that I have the right sign in my answer. Now I'm going to multiply straight across the top. 1 times 2 is 2, times 2 is 4. So I get -4 in my numerator, and then 1 times 7 is 7, times 3 is 21. because I simplified before I multiplied, I now have a fraction that cannot be reduced. I have negative 4 over 21 as my answer. Let's take a look at one more problem. I have x times y. 3/8 is my x, and y is negative 2 and 2/9. So again, I can see right away a positive times a negative is going to give me a negative answer. So let's keep that in mind as we go through this problem. Since one of my two fractions is a mixed number, I'm going to turn that into an improper fraction. So I will drop 3/8 down, and I will multiply 9 times 2, get 18, and add the 2 of the numerator in. So I end up with 20 over 9, keeping in mind that it's negative, so that I will get a negative answer when I multiply. I can again simplify some things. 3 and 9. 3 will divide equally into 3 and 9. So I'm going to make the 3 into a 1 and the 9 into a 3 by dividing them both by 3. Also, 8 and negative 20 are both divisible by 4. So 4 goes into 8 2 times, and 4 goes into negative 20 5 times. So I will make that negative 5. Now I can multiply my 1 times my negative 5, and I will get negative 5. And I can multiply 2 times my 3, and I will get 6. So x times y, or 3/8 times negative 2 and 2/9 equals negative 5/6. Why don't you try 3b and 3c on your own? Finally, when we get to example 4, it says the first hill on a certain roller coaster is 255 feet tall. The first drop on another roller coaster is about 11/20 as tall as the first roller coaster. For the height of the hill on the second roller coaster, find the height of the hill on the second roller coaster. To find the height of the hill on the second roller coaster, multiply 11/20 by 255. Well, 255 is a whole number. We need to turn it into a fraction by putting it over 1. Then we got to ask ourselves, can I simplify anything? Well, 20 ends in a 0 and 255 ends in a 5. So I am able to divide both of those by 5, and I should be able to reduce it. 25 divided by 5 is 5, leaving me 5 divided by 5, which is 1. Now that I have simplified that, I can multiply straight across the top and straight across the bottom. I'm going to get 4 on the bottom, and I will get 510 plus 51, or 561 on the top. I will then need to change that into a mixed number by dividing 4 into 561, which goes 1/40 and 1/4 times. So the height of the hill on the second roller coaster is 140 and 1/4 feet tall. Why don't you try 4a and 4b?